This is Saujanya, physics faculty. So today we'll just go with the Louis method. So Louis method comes under X-ray crystallography. So what is meant by crystallography? Generally it's a technique used to study the structure of the crystals by using the X-rays. Okay, so it is used to study the structure of the crystal by using the X-ray phenomenon or by using the X-rays. So the question arises, why only the X-rays? So X-rays has the concept of diffraction. So because of the diffraction phenomenon in X-rays, they are generally used to study the structure of the crystal. Okay, so Louis was first method which is used in the X-ray crystallography to study the structure. So let us go with the experimental arrangement. So before going to the experimental arrangement, let us see what is meant by diffraction. So bending of a light ray when it meets an obstacle is called as the diffraction. So generally how the shadows are formed. So when you just put an object, when light comes and falls on the object, we can see the shadow which is formed at the end. So that is defined as a diffraction. It's a general phenomenon. So by using this particular diffraction pattern, generally the Louis method is used. So let us go with the experimental arrangement. So here from the source, X-rays are released which are made to pass through the two slits S1 and S2. Okay, so since from the source the ray will be like this, so when they pass through the slits they become narrow. That was the major advantage of the slits we are using. When it passes through the slit, the width or the ray becomes narrow, right? So now in the vicinity of this we will place the crystal. So when rays comes and falls on the crystal, the rays will get diffracted and we have a screen placed here to observe the pattern. So this is the experimental arrangement of the Louis pattern or Louis method. So here source from the X-rays will pass through the two slits S1 and S2 and they are made to fall on the crystal. Okay, from the crystal the rays will get diffracted or they get refracted and they fall on the screen. Okay, so the pattern on the screen can be observed in this way. This is a fashion where we observe a dark band with the light bands. So a dark band with the light bands which shows the pattern of the diffraction. So this is the pattern. So by studying this pattern we can find the structure of the crystal. Okay, so now how this pattern is used to study the structure? That was the question. So what happens when X-rays comes and falls on the crystal? What is happening inside? So we know that crystal is made up of space lattices. Space lattices are nothing but the imaginary points. They are nothing but the imaginary points. So when we consider some space in a 3D dimension, each molecule or each atom is imaginary. So let me assume that I have the molecule before me. So each and every atom or the molecule is imaginary. So that particular points are imagined and joined together. Right? So when light comes, X-ray comes and falls on any lattice point. Okay? So half of the ray will get reflected and half will be getting diffracted. So this is the pattern. When light comes and falls on any object, half of the light will travel through it, half of the light will get reflected. The same thing is happening here. If theta is the angle, A is the ray and B is the ray here, BC is the refracted ray and angle A is the incident ray. So now join A to M and B to the N. So joining them by using the mathematical calculations, that is by using the Bragg's equation, by using the Bragg's law formula, n lambda is equal to 2d sine theta. We apply this Bragg's equation to this particular phenomenon and we write the equation as n lambda is equal to A into alpha minus alpha naught, where A is the interplanar spacing. What is meant by interplanar spacing? The spacing distance between them. So if we have two imaginary lines, the space distance between them is called as the interplanar spacing. So by studying the interplanar spacing, we can find out the structure of the crystal. So A is the interplanar spacing, lambda is the wavelength of the X-rays, whatever we are sending here, and alpha naught. Alpha and alpha naught will be the incident and transmitted rays what we observe. Okay, so this is for the first one. For example, we have one more plane, then this is the pattern. That angle will be beta. So n lambda is equal to A into beta minus beta naught. Okay, similarly, n lambda is equal to A into gamma minus gamma naught. So depending upon the number of the lines, we will be having the different type of the patterns. And by studying this pattern, we can find out the structure of the crystal very clearly. Okay, so Bragg's is the phenomenon which is basically used to find the structure. Okay, so how does the lattice structure helps us to find the, how does the studying the lattice points helps us to find the structure? So let me say that each and every crystal will be having the individual structures. So let us consider ourselves that this 5 points will be the cube structure and last 5 points will be the tetragonal structure. So arranging each and every lattice point will be different. So by studying the interplanar differences or interplanar value, A value, we can find out the structure of the crystal, whatever we are doing here. So Louis method is one of the particular pattern which is being used in laboratories to study the structure. Even now, we have this pattern, we have this experimental arrangement to study the structure. Any new solid material is fabricated, we use the Louis structure or Louis method, which has been in the different international institutions where we can go and study the structure. And this is the advantage and the study of the Louis method. We have one more method apart from the Louis method, that is called as the powder method. Okay, so to study the crystal, it is okay. But what happens when the crystal is made into the powder? There are certain amorphous materials. Amorphous materials, example is salt, sugar, any powder material. So Louis method is one particular experimental arrangement used to study the structure of solid. But when you want to study the structure of the powder materials, we need one more certain material or one more certain experimental arrangement called as the powder method. Okay, so the name itself is the powder method. So powder method is basically used to find the microcrystalline structure of the microcrystalline substances. So generally, it also uses the concept of the diffraction technique of X-rays. Therefore, it also comes under X-ray crystallography. Okay, study of the structure of the any material using the X-rays. Okay, so let us go on with the experimental pattern. So we have the X-rays released, which are passed through the slit as usual. Okay, they come and fall on the crystal. They don't have the crystal. We have a screen here, and screen will have a pouch type material where the powder is filled. For whichever material or whichever powder you want to find the structure, that particular powder is being filled inside the pouch, and this is attached to the screen. So this is the screen pattern here, which is attached to the screen, or we can say attached to the photographic plate. So this is the experimental arrangement of the powder method structure. Okay, so here instead of using the crystal, we use the powder method or a powder material. I can just take this chalk piece and I can also do this. It's a normal method. By using the diffraction technique, I can take a chalk piece, I can make it into a powder, and when laser light comes and falls on this powder, I can find out the structure of this each and everything. Size also, I can find the size of the each particle also. The same thing goes on here. So when the light X-rays travel through the slit, when they come and fall on this pouch, which has the powder material and which is attached to the screen. So now, when each and every X-ray particle So when each and every X-ray particle, so it is powder. So when each and every X-ray particle comes and falls on the each powder particle, so every particle will get diffracted or they get refracted. So all these refracted particles which are traveling in the same phase, they form one particular band. As we have learned in your second year optics, so we know how the dark and bright bands are formed in the optics, like diffraction concept. So when particles, all the particles which are traveling in the same phase, they come and fall on the one band, which are traveling in the other phase, they form the one more band. So this is observed in this fashion. If I am going to observe the photographic plate, so length 1, length 2, length 3. So all these are the patterns. We observe it on the photographic screen or photographic plate, and each length will represent the size of the granule. Size of the granule, or I can say size of the particle. For example, if I have just crushed this particular chalk paste into the number of particles. So each particle size can be observed on the photographic plate. And by using the formula, theta will be equal to pi by 360 degrees into L1, and theta 2 is equal to pi by 360 degrees into L2. Using these different formulas, we can find out the different angles where the light is getting reflected. So when it is getting reflected, when we have the values of the theta 1, theta 2 and theta 3 and so on, using the Bragg's equation, n lambda is equal to 2d sine theta, we can find out the value of lambda, or we can find out the value of the interplanar distance. So interplanar spacing. So for example, if this is the solid material we have, this is one imaginary line and this is one imaginary line. With the distance between the interplanar spacing, we can find out the structure. Because we have 7 different type of crystal systems: cubic, monoclinic, orthorhombic, rhombic, tetrahedral, etc. And each structure has the different spacing between them. So by using the value of the spacing value, we can easily say which type of the structure it belongs to, right? So this is one of the method in which X-ray crystallography is used, that is called as the powder method, which is not practically used as compared to the Louis method. Because whatever the new material we generally fabricate, we try to use the solid material. So we only use the solid material, we fabricate it as a solid material, we create it as a solid material, and we try to find the structure. Therefore, powder methods are generally not used, and it is not comfortable for the practical purposes also, right? Any doubts?